Calculus, Unit 1, Day 3 notes. This is Part 4. On this first part, we have to go through and come up with, we're given a graph, and we have to come up with the equation of each piece of this piecewise function. Um, so the first one here, and let me make sure my pen is correct. I see that as I'm coming down here, I have a slope down 1 over 1, down 1 over 1, so there's negative 1 for a slope. And I got to calculate. And there's a couple ways I can do it. I can take the slope and take one point here and find out what the y-intercept would be. Or for me, I'm just going to go down 1 over 1 a couple times until I see that the y-intercept is negative 5. And where does this constraint for this piece occur? It's when x is less than negative 3. Let me skip to the what I have here at the end. The second linear function from here, down 1 over 2. So I have a slope of negative 1/2. And same thing, I can just start here and go up 1 over 2, and I see that my y-intercept would be at negative 1. So negative 1/2 x minus 1, and this is where x is greater than 2. Notice it's not equal to it. And the last part here, a little bit harder, and I have the vertex form of a quadratic, so hk is where the vertex is. So I look at my graph and I find out that my vertex is at negative 1, negative 6. Hey, so I know the h and k, I can pick any point, and so I can pick this point right here, negative 2, negative 5, substitute those in for x and y, and I can find my a value. Okay, and I find out a is 1. And then for the parabola, it's x is greater than 3, negative 3, excuse me, it doesn't include the negative 3, and it goes all the way up to when x is less than or equal to 2. Okay, so we're going to use these three to come up with some equations. So the first one, hey, 2 from the right, I know it's going to be dealing with the line over on the right side. I just substitute in the limit as x approaches 2. I need to know that the limit from the left, which I use the quadratic equation I had up there in the middle, I get 3. And then compare that to 2 from the right, which I just did in part A. I find that's negative 2. So 3 does not equal negative 2, therefore it does not exist. Okay, and they want the reason why. And then I have some here that you guys can take a look at. They don't ask us on C and D to come up with the limit of the function, but since the limit from the left equals the limit from the right, we know the limit of the function as x approaches negative 3 would exist, and it would equal the same value, negative 2. Okay, so just take a second to look at these, then we'll go on to the next page. So now we're given a new function, a quadratic when x is less than negative 2, and a linear function when x is greater than negative 2. So they want us to first find as x approaches negative 2 from the left, so that's going to be dealing with the top equation, so I just do direct substitution. It's a one-sided limit, and I get 2. Do the limit from the right side, that's going to go into the bottom equation, I get 2. And there's always some confusion. People think, well, hey, next they want to know the limit as x approaches 2. Well, it's not defined at x equals negative 2, but they're not asking that. They're not asking for the limit as x approaches negative 2. And the limit exists because the limit from the left is equal to the limit from the right. They're both equal to 2. Therefore, the two-sided limit as x approaches negative 2 is going to be equal to 2. Okay, let's go on to the next page. Okay, we're looking for some of these limits analytically. One of the things I always want to check, first of all, can I do direct substitution? And obviously, if x was 0, I'd get a 0 here. So some of the things, again, we're looking at is direct substitution. Can I factor and do some cancellation? And hopefully when I do some cancellation, I'm canceling out whatever made it undefined, where the limit would not exist. So again, direct substitution is always first, cancellation, and then rationalization. Okay, so hopefully you're trying some of these and then just checking your work. I'll leave these up here. Take a few seconds to look at these. Again, just pause the video so you can check your work as you go. We can go over these in class as questions come up. Next page, check these two. The first one doesn't exist. You can't cancel anything. Direct substitution doesn't work. There's no way to rationalize, so it doesn't exist. This one, 8x cubed minus 27, is going to be the difference of cubes, and it's 2x all cubed minus 3l cubed. It's not 2x quantity all cubed. So I know that's a mistake that happens every now and then. Okay, let's look at some ones down below. Here's where we're going to rationalize. It's radical plus 1. That'll end up being the difference of squares. My suggestion is not to distribute the x plus 2 over this problem, because most of these problems, this is 2x plus 4. I factor out a 2, and obviously we see we can cancel those out. Okay, so we get 2 all over square root of, and we get 2 over 2 equals 1. Same thing. I cheated a little bit. I didn't show all my work. I didn't rewrite the denominator. Again, I didn't multiply them together. Just left them, actually I didn't distribute, I just left them as the product, because when I did some simplifying I was able to cross out these factors x minus 1. And by canceling that factor, which made it undefined in the beginning, is now going to allow me to come up with the limit, and we get negative 2. Okay, on the next page, J, we do a bunch of work. We find out we still can't cancel, so the factor of x would not cancel through any algebraic means. Therefore, I know x equals 0 is a vertical asymptote, that's going to exist graphically, meaning the original limit of the original function as x approaches 0 does not exist. Okay, so a lot of work and to find out that nothing happens, but you have to go through those steps. Again, can I direct substitute? Can I cancel? Can I rationalize? And in this case, I did all that, and none of it worked. These next few problems, we want to, in this case, factor. I can cancel out x plus 2's, which would make that, oh no, so those end up canceling out, and I still have an x minus 2. If I substitute that in, I'm going to get 0, but I'm approaching it from the right. I know I can have a positive infinity or a negative infinity as a one-sided limit, so I choose 2.1. Just want to find out really what are the signs, positive over positive, therefore this is going to approach positive infinity. Do the same thing down here. It's the same function, but we're approaching 3 from the right and 3 from the left. So 3 from the positive side, I'm going to choose 3.1, get positive infinity. And over here, I just substitute in 2.9. Again, positive over negative is a negative, so this is going to approach negative infinity. Okay, so that there is a vertical asymptote there. It's a one-sided limit, so I know I can approach positive infinity or negative infinity. Okay, this last one on this page. This right here will play a much bigger role in what we're doing for limits in the next topic in calculus. So right now, what I'm doing is I'm taking the limit of a function as h approaches 0, f of x plus h. So all I did is take this, every place I saw an x, I substituted in x plus h. And then all I did here is simplify it, and then same thing, can't combine like terms. Minus f of x, so I had to distribute that negative sign, so all the signs became opposite. Canceled out what was the same, and I was just left with 4xh plus 2h squared minus 3h. I factored out an h, which is what made it undefined in the first step, because h is approaching 0. And now I'm at a point where I can direct substitute, and I come up with the limit equals 4x minus 3. Pause this and take a second to look at it, and hopefully, if you couldn't do it, you at least understand how we got it to work. Properties of limits. Limits of a sum is equal to the sum of the limits. Limit of a difference equals the difference of limits. Limit of a quotient equals the quotient of the limits. And these will make more sense on the next page and as we do some more work. Limit of a product equals products of limits. 5 and 7 are kind of connected. Limit of a constant as x approaches a is just a constant. But first I can use this as the limit of a product, break it up into the product of limits, and then I know the limit of a constant equals just that constant. This limit equals L. Now I have a limit of a function being raised to a power. I can take the limit of the function first, get an answer, and then raise it to a power. Okay, so those are going to be our properties of limits. Last page here on the day 3 notes, given a couple graphs, but what I want to do is I want to use my properties of limits. So here, the limit of a sum, break it up to the limit of f of x as x approaches 2 from the left. And let's do that. 2 from the left is going to be right here. So hey, is the value, that's f of x. Limit of g of x as x approaches 2 from the left. And so over here I get 3. Over here, g of x, I get 1. 3 plus 1 is 4. So you could go and combine the graphs and add them up, and it's just a lot of work, where now the properties of limits allow us to do that much faster. Okay, I'm just going to pause this. I'll give you a few seconds to look at each of these, see how you did. Here's the middle row on that last sheet. Again, quotient rule, product rule, power rule. And lastly, the last one. This we want to write, get rid of the radical and write it with rational exponent, and we'll be doing that a lot more as the course goes on. So we want to rewrite it, and then I can follow my properties of exponents. Again, limit of quotients, the quotient of the limits. Again, we just look at the graphs and say, hey, as I approach from the left, right, two-sided limit, whatever. And again, even with a hole, or more in terms of a jump discontinuity or vertical asymptote, one-sided limits can exist. Okay, so hopefully that was helpful. Continue working on homework 3, and we'll go over that next class. And we'll have some time to finish it if we didn't get there.